Okay. All in favor of booting Nathan?
Wow. Wow.
Hey, man, you deserved that.
All right. Well, I'm not going to wait for everybody else. Let's see.
Let's get started with this PowerPoint.
Yeah, about that. All right. Next Wednesday, week from today, we're going to take a quiz over this stuff in here, timed. You have an hour to do it. There are 21 questions over the PowerPoint. And today, we're going to review some of the math, do some examples, make sure everybody's on the same page with how to do this stuff. And yeah, get ready for that quiz.
Is it going to be accessible over phone?
No, it's Blackboard.
Okay.
Well, I get then yes. I don't know. It'll be on Blackboard, timed an hour. 15 multiple choice and 6 math questions. Okay?
Okay.
Okie dokie.
So I hope all the people that aren't here figure out that we have a quiz next week. Who did I not mark down? Brady's here. 6 of you. Brady. Kenzie. Brayton.
Nathan, I can hear your Animal Crossing game. Turn it off.
I'll turn it down. It's fruit day. I gotta collect all my fruit.
Oh my god.
Hey, that's a lot of money right there.
I know. I get like 35,000.
What's going on here? No. Okay. Shall we begin?
Sure.
Yes.
Okay, let's go over some formulas you guys can take notes on and use for the quiz. If I said, what are the units of work? What would you tell me?
Units of work?
Horsepower?
No, isn't it foot pounds?
No, that's torque. Horse times distance?
Yep.
No, never mind. I'm an idiot. Which is foot pounds, right?
Yeah.
Right. It's a force over a given distance. So foot-pounds, right?
Yeah.
Can't change the freaking. Why can't I change the font? There we go. There we go. Okay. What about torque?
Why can't I see? Oh, there we go. Oh, torque.
I feel like that's also feet times pounds, foot-pounds.
Yeah, I could say I have 2 pound-foot of torque. It's the same units, right? The only difference is work is linear and torque is rotational.
Hmm.
So torque is technically a unit of work, right? It'd be like force, distance, pound foot, foot pound. What about horsepower?
RPMs, right?
Horsepower is not RPMs.
Is that
Isn't it
like
work?
like work times time?
Yeah.
Not times time.
Per time?
Overtime?
Work
Yeah.
per time?
Horsepower is a work
Divided by time.
done in a given amount of time. So what does 1 horsepower equal?
Like 33,000 something?
33,000 what?
Foot-pounds.
Foot-pounds?
Pounds
Oh.
per minute.
Pounds per minute? Foot-pounds is wrong. Pounds per minute is wrong. What's the unit of work?
Foot-pounds.
Foot-pounds.
Feet per minute.
It's just pounds?
Okay.
Foot-pounds
So
per
if
minute.
horsepower is work per time, work in a given amount of time. 1 horsepower is 33,000 foot-pounds, which is work.
Per minute.
Given amount of 33,000 foot-pounds per.
Second?
No,
I'm muted. Per minute.
per minute. There we go. Good grief.
Well, he was
I
saying
said
that
it.
a lot, so that's why I figured
Who was saying
it
that?
was wrong.
Me.
Nathan was.
Oh, I couldn't hear you. All I heard was blah, blah, blah. My name's Nathan.
Oh my gosh.
That's what it sounds like, yeah.
How many watts are in a horsepower?
Enough to break the
746.
ice.
What did Brady say?
746.
Thank you. Okay. Everybody got written down? Good.
Oh.
One of these. What'd you say? Somebody want to go back?
No, Brady said yeah.
I need to.
Yeah.
Yeah, I
I
was
need to see
writing
it real
down.
quick. I'm almost done. Give me a second.
Guys,
Did I give
literally,
you more time since you were late?
I appreciate it.
It's all right. I'm late from time to time too. I'm an understanding individual. How many people are here now?
It's been a rough week.
4, 8, 11?
Damn. It's only Wednesday.
Yeah. Well, I'm also going through a divorce.
Is Luke here? No.
Sorry, man.
He's not here. Brad, Brady, Don's now here.
All right, I'm all good, but I don't know if anyone else is.
I took a picture of it, so I'm good.
Yeah, one more to write down, then I'm done. Give me a second.
I had a dream last night that there were
I'm good.
40 CNC LAPs.
It's not a dream. It's a nightmare.
When are we kicking Nathan out?
Oh my gosh.
I'm good now, Zach. We can move on.
Okay. All right. So remember this thing?
Mhm.
I think one thing that would be helpful with this, you know what? I'm going to wait on that. If I told you I just lifted a 5-pound monster 5 feet in the air, how much work is that?
1. That is 1 foot-pound.
You are totally wrong.
25 foot-pounds.
25.
Oh, yeah.
We're not dividing, we're multiplying. If I told you that I'm holding this, I'm moving this, what did I say, 5-pound monster?
Yeah, which is wrong.
No, it's 5 pounds. And my arm is 3 feet away from my shoulder. What's the torque on my shoulder?
15 foot-pounds.
15 pound-foot of torque, yep. If I told you what else am I telling you? Nothing. Okay, now we're moving on to this.
Could you go back to that last one? I understood the first one, but your arm is 5 feet away. 5 pounds.
Right now, is there a 2-pound weight working downward on my hand? Do I feel
Well,
2
we
pounds of force or
No.
5, whatever it is? Do I feel 5 pounds of force on my hand?
Yes.
Yes.
Technically.
Do I feel 5 pounds of torque on my shoulder?
No.
No, I feel 15 pound-foot of torque on my shoulder, right? Because it's 3 foot away.
Okay, now
Oh, okay. That's the 3.
Yeah.
Mhm.
that's what we. Okay, thank you. That was it.
Yep.
Proud, Bob. Okay. Can everybody? Is this blurry at all, or if I put some numbers in here, we're gonna be okay? Like, let's say.
We're gonna be good.
Let's say this is 80 feet. Let's say this distance is 12 feet. Let's say it's spinning at 20 revolutions per minute. Let's say how many tons? 2.5 tons. Whoa. 2.5 tons. Okay.
So 10,000 pounds.
What are you talking about?
5,000 pounds.
5,000. Sorry.
I haven't even asked a question yet. Oh, 5,000 pounds. Yeah. How many pounds are in a ton?
I thought 4,000, but apparently it's
Times
2,000.
1,000.
2,000 pounds in a ton. Oh boy. So you can use your uglies book. You cannot use Google on the quiz. And I can see all of your screens right now. Did you know that?
It's true. He can.
Wait, you can see my
Creepy.
phone screen right now?
Yeah. Like I can see who you're texting right now.
I'm on a Zoom meeting. Now I am, but that's funny.
He could do it with Zoom and Blackboard, but if we don't have any of those open on a separate device, you're all good.
No, I have access to your cameras as well.
Okay,
I'm so sorry. I'm so
I'm-
sorry.
the FBI hooked you up with that one?
NSA. I'm pretty creepy. Okay, let's just leave it at that.
That's
A
funny.
couple street-
All right. How much horsepower is this guy doing?
So 5,000 times 12. So 6. Wait. Why can't I do that in my head? 5 times 10 is 50.
Is it that
60,000.
simple? What about the 80 feet?
That doesn't matter.
What about the revolution
Are we-
per minute?
Are we assuming?
Are we assuming non-existent frictionless?
Yeah, frictionless.
Okay.
Yeah, that's exactly right. And I'm glad that you guys were paying attention when I explained that. Another way I'd like to look at this is just to say, okay, this is hang on. This is 2.5 tons worth of whatever. Okay. And it's being lifted 12 feet.
Hey Zach,
What?
I have a question. So, for all this math that we're doing, is this for sizing motors that we would put on basically like conveyor belts and that kind of stuff? At one point, would the horizontal distance increase horsepower enough to where we'd want to add that in?
That's a really good question. I guess my answer would be whatever answer we come up with here. If we come up with, okay, I need 2.93 horses of a motor to do this. Are you going to size it at 2.5? Are you going to size it at 3? Are you going to overdo it?
Yeah, you'd want to overdo
know?
it based on like what the code would put in, but
Right.
I don't know if that'll be enough.
So I guess for the purposes of my work experience, I would say, what are we looking at here? Are we looking at something that's really going to be moving 2.5 tons where that friction would be coming into play? And if it is, you might want to do a little bit more math, you know?
Okay.
But to do that, you need engineering type stuff. I mean, it's not as simple as just using the raw numbers. You have to have coefficients of friction, like on the rollers that are, carrying that belt. I mean, there's all sorts of crazy stuff that you probably have to have an engineer for. But for this sake, like, I don't know. If I'm on the job and I'm doing this for a rock crusher plant, they're building this and they need a motor, and I came up with I need at least 3 horse, I'd say let's get like a 10 horse motor, And
Okay.
not really. I mean, you gotta use your head and see what the price difference is between that. But I would explain that if it's really a customer, I'm gonna say, hey, here's what I'm coming up with. I would oversize it just to be safe, and then it's your money. Like how safe do you want to be on it? You know, if they want to spend, you know, several $1,000s more for a bigger motor, then so be it. You know, but at least this way we're not just like, okay, wow, there's a conveyor. That looks like I'll need about 1 horse, you know, and then you're wrong. At least you can do the math and figure it out. Does that make any sense?
Yeah.
Okay,
Yeah.
Mm,
Then you
did
got to
think-
put the horse down.
that's right.
Jesus. Old Yeller.
Any of you guys watch Ed when you were a kid?
Watch what?
Is anybody as old as me in here? No, probably not. Ed,
I don't know.
horse. Never mind. Moving on.
Just,
Oh, okay. So here's what I'm saying,
It's just a fail.
just a disappointment.
Brady. I don't fail. Okay.
All right, my bad. You just don't succeed.
If at first you don't succeed, you can dust it off and try it again. Dust yourself off and try it again. Try it again.
What if you don't
Okay.
succeed twice?
What?
What if you don't
You
succeed
failed
twice?
twice.
You're just done.
Okay, so we're looking for horsepower. This is another way I would think of this, because since this thing is frictionless, all we're really doing is lifting 2.5 tons, 12 feet straight up, right? Don't get confused with the distance this way, right? So if we're lifting 12 feet, 2.5 tons in the air, and the question says we're moving this thing 80 feet in every minute, or it's lifting it 12 feet every minute, what's our horsepower? What's the first thing we need to do?
Find the diameter of the pulley.
No, we don't even really need to take torque into account here.
Okay.
You asked how much horsepower, so we just take the weight times the distance.
Yeah. Well, the first thing I'm going to do is I'm going to write down what the formula for horsepower is. 1 horsepower is what?
33,000.
33,000 what?
Foot pounds.
Foot-pounds per minute.
Foot-pounds per minute. Right?
Mm-hmm.
So how many foot-pounds is this?
Two and a half tons would be 5,000 foot-pounds. Or no. It'd be
2.5
the
tons
weight
of pounds.
times the feet. So it'd be 2.5. That'd be our pounds, and our distance would be 12. So it'd be 60,000.
5,000 pounds times 12 feet.
Yeah.
Equals 60,000 pounds. No, 60,000 foot-pounds.
Yeah.
Okay, so how many horsepower is that?
Find a calculator.
How do
Just
you
divide
calculate?
it.
.81 horsepower.
1.81 horsepower.
Wait, we don't have minutes though. Or are we just saying that that's the amount of work that it's doing in 1 minute?
Yeah,
So-
because the question I asked was if we're lifting 2.5 tons, 12 feet in the air every minute.
Okay.
I don't know if you caught that part. It was very minuscule. Yeah. What if I asked you what torque it was feeling on the shaft? I guess I should tell you that this is
In that case, you have to find the circumference of the pulley.
3 foot. 3 foot diameter.
So circumference times the rate per minute.
What?
Would be the circumference of the 3 inches, or is it 3 feet? 3 feet times the rates per minute. They give us feet per minute. Since it's force times distance.
Okay. Torque equals force times distance. What is our force?
The
Um,
60,000 foot-pounds. Or, wait, no.
Just
So,
60,000.
which is the
5,000
5,000
pounds.
pounds.
Yeah, we're really only we're only taking that same weight,
Times 80.
5,000 pounds, and however far away from the shaft. We're not taking into account the work being done by the motor at the same time. I guess what I'm saying is you're assuming that the conveyor is sitting still, and we're just finding what is the torque felt on the shaft, right? The same way my whatever was being felt on my shoulder. So in this case, it would just be what are we doing?
Smooth jazz.
5,000 pounds times 1.5 feet. So it'd be 7,500 pound foot.
Yeah.
Okay, so just to be clear, this was one question. What if I said, how long does it take to lift that weight 12 feet in the air?
So wouldn't that be?
Wouldn't that just be a minute?
Horsepower.
Forget the minute. Let's use the
work times time.
In this
work divided by time. My bad.
Hody-do. In this example, I gave you 1 minute, right? Let's take that part out of the equation and use the information that's on that picture. A totally different question now. How long is it taking us to lift that thing 12 feet in the air?
Will we have our revolutions per minute?
We got 20 revolutions per minute. I have to go ugly here so I can keep my units together. So 20 And in 1 minute, or in one revolution, how much distance are we traveling with the belt?
80 feet.
80.
Oh, sorry, with the at whatever the circumference of the pulley is.
So half times pi.
Yeah. So what's the circumference of the pulley?
3 times pi.
3.14 times the diameter, which is 3. And that's feet. So these cancel. And we know that that thing is covering. Anybody got it?
9.42.
What?
9.42.
9.42. What?
Wait, isn't 9.42 just 3 times 3.14? Don't we have to multiply by 20 as well?
Yep.
Yeah, so times
20.
20 then.
9.42 times 20 is 188.4.
188.4.
Yes.
Okay, and what's the units?
Feet
But
per
feet
minute.
over minute. Yeah.
Feet per minute. That's all we're left with. Okay, 188.4 feet per minute is what we're covering with that pulley. So how long does it take to cover, I guess I'll just leave it to the question. How long does it take to cover the distance of lifting that thing 12 feet in the air?
So do we
Or you
use
just
the
multiply 188.4 times 12?
Not 12. We're lifting it 12 feet in the air, but we're actually covering 80 feet of distance, right? That's where the 80 feet comes in.
Oh, okay. So let's multiply by 80. Right?
No, we're not going to multiply it by 80. We're
Divided.
covering 188 feet a minute. And I'm only going 80 feet. Do you think it's going to be more than a minute or less than a minute?
It'd be like half a minute.
Yeah.
Okay, I see what you mean.
We're dividing by 80,
Gotcha.
which is the same as saying 188.4. I have to do it slow so you can actually read it. Feet per minute. If we divide it by 80, it's the same as saying times 1 over 80, right? Times 1/80th.
Yeah. Okay. Once it's written out like that, I understand it better.
And then these cancel, and you're left with, so 188.4 divided by 80 equals
2.355
2.35-ish minutes.
minutes. Gotcha. Luke, when did you change your picture, bud?
Well, I just haven't been signing in lately, so I just
Yeah,
thought,
that's very nice.
yeah, thought I'd bring it back.
Yeah, well, it never left, so that's kind of why we're in the situation.
That's very true.
Hey, Zach, didn't we say it was going to take less than a minute?
Yeah, we're taking, yeah, I'm sorry. I screwed that up. It'd be the other way around. It'd be 80 divided by 188.
But because minutes have to be on top,
Huh?
like I said, end up on top.
No,
Never
feet's
mind.
still on top. It's-
So we're going 80 feet and traveling 80. Yes, we're traveling 80 feet. I hate it when I screw with your brains like that. Traveling 80 feet. And if we divide it by, if we divide it by, what is it? What is it? 188.4 feet per minute. That'd be like saying times 1 over.
Yeah, you take the reciprocal. So yeah, so minutes end up on top.
Yes, never mind, you're right.
Yeah,
Okay.
I screwed up. My bad.
No, it's okay. I'm just glad that we caught it.
Yeah.
That was a good catch.
Thanks, Jay. What is that?
Let me get it real fast. It's 0.424 or 0.425 if you round up.
There we go.
Got it.
All right. Okay. That's it for the math review. There's just a couple more things in the PowerPoint that I want to. Whoa. Point out to you. Speed, torque, practice. I don't remember if we got this far or not. All right, I won't go through all of the rest of the slides, just a couple important ones. So on this, have you seen this slide before? I think we already went through this.
Yeah, but you
Is it?
said we weren't going to go through all of them.
No, we're not, but I can't remember where we left off. Anyway, on this slide, the important part is if you have a load on a motor, if you increase the load on the motor, what also increases? Current, horsepower, torque.
Wouldn't it be the torque?
Just the torque?
1 horsepower.
Keep reading, come up with an answer together.
Okay,
Current's
so
gonna
there's
go
no
up.
load, there's no load, no shaft torque. So that means that load goes up then. Okay, so torque is one that goes up. And then current would have to go up too if they're closely.
Bingo. Say that one more time.
Current,
And
torque.
yay.
Yay.
Um, when you start a motor up, if you're not using a drive, if you just energize a motor, will that motor experience higher current than normal?
On startup, it should. On startup, it would, right?
Yeah, it does. So if the current's way up, what also is way up?
The torque.
The torque. If a motor is stalled, how much torque is there?
0?
0.
0, right?
Yeah.
Correct.
Okay.
Am I muted? Nope. Cool.
Did we kick Nathan out yet?
No,
Yeah.
but that's why we're
Still here?
ignoring him. And it's working because he thinks that his mic is muted. So it's the same thing. Hey, you called me fat. You brought this on yourself.
I call myself fat too.
You didn't
Nobody
say
Look, it
that.
doesn't matter.
I didn't say you're fat either.
You
Yes,
didn't say that.
Nathan.
You kind of did.
Thank you.
You said, "Are you calling me fat?" And I said, "No." I said, "Well."
You said that's a different matter. That's
Yeah.
It's a different conversation.
That's
Conversations can also end in no's.
yeah. Thank you, Brady.
You remember what I told you? Motor manufacturers are required to be within a certain amount of efficiency.
Yeah.
yeah.
What was that percentage?
8%.
Who said that?
Brady.
Yeah. So say it louder because you talk.
80%.
80%.
8
80.
AD 80. Look at
My
this
girlfriend.
graph. When is a motor the most efficient? If you look at this graph,
It kind of looks like 90.
and I'm not looking for the percentage value. I'm saying when, like at what point?
At the peak.
Oh,
Right, but when it's low speed, high speed, full load speed,
Full load. In between. Full load.
full load. Motors are designed to be most efficient when they have full load capacity on them.
That makes sense.
Why do you say this? Why would you say it's not super efficient when there's 0 load on it?
Because that's not what they're made for.
would overload it.
If there's 0 load on it, how much torque is on it?
None.
0.
None.
None.
Just get hot.
It's getting hot in here on this motor. How is loss in a motor? You should know this.
Heat.
Heat.
Heat from friction.
And when would a motor overheat the quickest?
When it's at its maximum load. Or it's stuck.
Stall speed?
Stall speed. So you
So
got.
does that mean if it has
you
like
got-
a
It's stalled speed, which is right here at 0.0. You've
Yeah.
got 0 horsepower and the maximum heat. And when do motors burn out?
well, couldn't there be a number of things? Too much friction.
Yeah, it could be another
guess
thing,
that's
but
what you're-
assuming there's no like ground faults or anything like that.
Right.
If it's overloaded?
Overloaded for a long time. Whoa. um. Yep. Okay, the remainder of this PowerPoint is not, so anything after this slide, anything after slide number 60 will not be on the quiz.
Quiz.
You can look through that. It is handy information. It talks about when to rewind, have a motor rewound or replaced, or usually like what I've seen in the field has been like, hey, this big giant, really expensive motor is, you know, the T1 to T2 windings are shot. Is it more expensive to rewind it? Well, I'm not one to rewind a motor, so I would call somebody who does that. There are some motor repair places in Peoria that you could just call them and say, hey, I've got this $8,000 motor. How much would it cost to rewind this thing? You know what I mean? But it gets into efficiencies and logistics of that kind of stuff. Okay, but the quiz will be based on the math that we covered today and all of the, I didn't go over all the slides in here over the last couple weeks, but I did highlight a few things if you recall. So the YouTube video of, I think it was 2 weeks ago when we started into the PowerPoint is online, and then the video of today, if you want to review, will be online as soon as it gets loaded. Any questions? Any questions about next Wednesday?
That's the quiz, I'm assuming, since you said
Next Wednesday at 10 a.m. is a 1 hour long quiz over this PowerPoint.
Are we not meeting on Zoom?
We are meeting. You must be present
and
to
then
access the quiz.
Yeah.
Because that's the only way you'll be able to look your.
Huh?
Because that's the only way you'll be able to like see your screens.
Yeah, and to know that you're not all sitting in a Starbucks together, taking the quiz together.
That's a good idea.
I'm gonna go to
You're not allowed to.
Starbucks. I'm gonna drive 8 hours to go to Starbucks with you guys.
Hell yeah.
You know what I'm saying. I trust you, but I don't trust you because you're a bunch of cheaters.
I mean, that's fair.
I prefer the
Nathan, you're
term
still here?
innovator.
Why have we not kicked Nathan out? What'd you say, Jay?
I said I prefer the term innovators.
Innovators. Oh, okay. One more thing. Let me see who else here. I want to make sure Don is here because he had a Don's here. You here, Don?
Yeah, I'm here.
Okay, this is for all the folks who are in Electech 232. And remind me to bring this up Friday when we meet again for that class. But Don had a question about all of the labs that he wasn't able to get to. And I think what I've decided to do is there's going to be a final exam for that PLC class, right?
Okay.
The final will be you're on Zoom with me, taking over the software, and you're creating a program that I tell you has to do whatever with that trainer behind me, right? It's not going to be super complex, but it will involve the concepts that we learned in this class in 232. And it'll be timed and all that good stuff. That final is going to be worth the same amount of points. And I haven't crunched the numbers yet, but it'll be worth the same amount of points as if you had done all the labs. So there's a couple people who are done with all the labs that were on there already. They don't have to take the final. But if you did 80% of the labs and you're happy with that, then you can take an 80 on the final. Or you can say, maybe I want a 90% in that portion of my grade. You can attempt the final and I'll take whichever scores the highest, right? Does that make sense?
Yeah.
Because we had so many people with different amounts of labs that were done, I have to do it this way. And it's the only way that I can judge that you understand the concepts, right? So you can take the final. If you do lower than, like, if you had 80% of the labs done, if you get a 70 on the final, you'll still get an 80%. Does that make sense?
Okay, so whenever you say labs, are you talking about the robotic labs
No,
or
the
the?
232, the PLC class.
Okay, I just wanted to make sure.
Yeah, I did only like 2 of those.
Yeah, so you're probably going to take the final.
I'm gonna take the final. Yeah.
Okay. So what I did is I've created a scenario that will cover all of the concepts that were covered over the course of the lab. So if you can do all of those and show me that when we're Zooming together, then you get 100% on the final, right? And the labs.
Okay.
And I'll what?
For the Fennec Robot Labs, there was a
Fennec.
I always get the word wrong.
Yeah. Has
Anyway.
anybody even? I haven't looked. Has anybody been submitting those?
No, because I
How do you
don't.
want us to?
Huh?
How do you want us to? Because like I run it and then now it's not letting me move the robot. Like I can use the teach pennant, but I can't move the robot.
When I power mine up, it just gives me that gray screen, like nothing ever loads. But I took the download from the website, like I don't know.
Okay. Have you updated Java yet?
Yeah, I had to download it, like, so that's freshly downloaded.
Okay, so you're having trouble opening Robot Run. Okay. Hang out for a minute, Kenzie. What? Somebody else was having problems with their, like, you created a program and what's going on with it, Brady?
My robot wouldn't run. Like it wouldn't move it. So like I could only see one angle of the robot. So you couldn't. So when it got to a certain point, you couldn't tell it was moving something, but it was moving. Maybe that was just a problem me reloading it.
If you got the program in there and the program, like the logic of it is correct, that's all I care about. I mean, we're not going to get those simulators to be perfect, you know.
All right.
I don't care about that.
Do you want me to submit like a screen recording of it?
Yeah.
You mentioned something like a Zoom, and then I could, I don't know, like pin my video to the screen and then submit that Zoom to you.
However you want to do it. Just make sure you label. Let me do a screen share here. Nathan, did you have a question, real quick?
Yes, sorta.
Okay.
I haven't even looked at the Robot Run website yet. So been preoccupied with other things. But I know all I have are the last 2, the framework and the other one. Okay. What website, what does it look like? Is it robotframework.org or is it on Blackboard?
I walk you through that whole thing on that find that YouTube video.
Okay.
Hang on, I'll share it with you. Not that I don't want to walk you through it now, and I can if you can't get it figured out, but can you see this shared 231? Okay. Online meetings. So that would have been a Wednesday.
That was the very first class, though, when we went over that.
Okay. So this April 1st one. If you look over that and you still can't get it running, then let me know and we'll do an office hours Zoom chat.
Okay.
Okay, and then real quick,
See you guys later.
go to this folder is the one that I want you to submit those to. So just make sure nobody's turned in anything.
Dang.
Okay. Well, so Brady's question about how do I submit this? So you've got that robot run software pulled up. If you have a way to screen record either in a Zoom, I mean, you can do it that way where you share a screen, record it, and drop that video file into this.
Shared. So
Yeah.
I don't know if you want me to email it to you or that, but I see now.
I'd like it all to go here because it's so much data that I'd rather just use the Google Drive's free data capacity.
Yeah.
So if you can do that, that's great. If you can't do that, you can send me screenshots of the program like on the Teach Pendant, and then I can review that and just say, okay, that's right.
All right.
If that's easier. Does anybody know how to use the snipping tool?
Yes.
Yeah.
I know how to like print a screen. You mean snipping?
Does anybody not know how to do like a screenshot is what I'm asking.
Yeah, I know. Yeah.
So if you wanted to do it that way, if you're just submitting pictures to me, then you can use this snipping tool and you go new and you can make a screenshot of whatever you want. Right, so this could be your Teach Pendant and it'll just save that picture. And you save that as whatever. And then you can upload that to this drive. Does anybody not know? I'm going to put this in downloads. Does anybody not know how to upload something into the drive? Why don't I just explain it to you while we're still here and recording? We still recording? I think we're still recording.
Yes.
So I'm a student, and I'm probably going to have to give you guys access to edit.
What the heck?
Okay, so I'm a student and I've opened up this and I've opened up this and I say new, file upload, and I'm in downloads and this is the picture that I just the screenshot, but it's a screenshot of the CF Lab 5 screenshot. So I renamed it so my instructor can figure out what in the HE double hockey sticks is this. And then I double click on that and it's uploading. And it is not taking forever. And why is it taking so long? Anyway, that's how you would upload a file to. Oh, there it is, right? I can open it up, but I can say, okay, this is Zach's Lab 5, and off we go. Okay?
Okay.
All right. So, anybody else have any questions?
I have a bone to pick with you.
Me?
Yeah.
Go ahead.
I did Lab 3, and you didn't give me points for it. You
Okay.
bastard.
What was Lab 3?
It was the moving the ping pong balls.
Did you move the ping pong balls or the proto board?
I moved the proto boards.
I can always tell when somebody's lying to me virtually.
I'm not lying. I did that one.
He did it after I did. I watched him do it.
Don, stay out of this. Hang on. Actually, I do remember that. Because
He's telling the truth. I was the proto board.
you crushed the proto board like 5,000 times.
I did. I jammed it in the table a lot.
Okay. Okay, I believe you.
Need to do the rounded edges one and the 2 tool frames ones. And then I'm going to do all the CNC LAPs today. It's going to be fun and exciting.
Yeah.
Kenzie, shut up.
All right, I think we have like less than a month left. I don't remember when the last day of class is, but you guys better get to work on this stuff. Remember, you got
Graduation is May 16th.
Yeah, so here pretty soon we're gonna have to start scheduling like final exams.
Finals.
Electech 231, this class, there is no final exam for it.
Okay. So what do we do, Zach? Because like we have heard nothing from John Spuler.
About
anything. He just keeps telling us to do the progress reports.
Yeah, but we have nothing. Like, I'm literally about to just like send him the same thing each week, saying we can't do anything. Like, no progress has been made. Like, I don't know what he wants.
Okay.
Like
have you guys contacted him? Have you emailed him?
I mean, he's been going through the weekly reports, and everyone's been saying, "Hey, we're not getting anything done," but he hasn't changed anything.
Okay, well, email him. I will try to ask him too, but
Okay.
ask him if there's anything more that you need to be doing. Tell him you're concerned with your, that you can't be faulted if you're concerned and expressing it,
Well, I mean, we have in the past, and he's basically told us to go.
Be faulted, but
like you don't know what he's expecting out of you for the projects, or
he chewed all of our asses out for a solid half an hour one day in class because as a class we expressed our concerns and he did not respond to it well. So
he expects us to still get the project done while also observing social distancing and quarantine, which is ridiculous because Kenzie doesn't have access to Arduino or our old Arduino project, while I have built a table and the TV fits in it. I
but you're in Oklahoma.
But I'm in Oklahoma, yeah.
Okay.
So
all right. Well, I'll talk to him and see if I can get any answers.
I'll email him again, but yeah.
Yeah. The more people that email him collectively with questions, the better. Be nice.
Yeah. I am gonna be nice. I'm just gonna say like, hey, I'm in Oklahoma.
We're nice. It's not us.
And for me, I've just been working on it by myself without Tyler, because social distancing, and I work in a hospital. And I don't want to spread it more than absolutely necessary.
Yeah, I mean, and nobody's expecting you to break the law to get this.
There's talk that they're gonna extend it to like June. Like, what do we do?
It's not just June. They're talking about extending it into July too.
So the social distancing?
Yeah.
Well, and there's a lot. Well, there's also a lot of people think just because it's slowing down means we need to stop. Well, that's the same as saying, well, I could take off my parachute. I'm slowing down, falling to the ground.
Well, Nathan, I don't know if you've heard this since you're not in Illinois anymore, but literally Pritzker is talking about how it's supposed to peak mid-May. So that's why they're talking about extending it, at least for Illinois.
They've said it peaked 3 times already. Like, when is the peak going to stop?
I don't know.
When we're all dead, Don.
When it goes down.
Yeah.
I mean, that's kind of what a peak is.
So
Yeah, but when they've said that there's like they said that it peaked last month, they said that it's gonna peak this month. Now they're gonna say it's gonna peak next month. It's like, when is it going to actually reach the peak?
I don't know.
There are many
people-
peaks on your
people
way
said
up
that
Mount
on
Everest.
site too. That's the thing. They're like, oh, you're not going to peak now, but you're going to peak later. It never happens. Okay. We're all very disappointed right now.
This whole thing's stupid.
Agreed. I'll try. Okay, no, but like literally all this stuff.
Hey, Luke.
Yeah.
Okay.
Why don't you
Lindsay,
go
can
away?
share your screen so we can take a look at your.
I'm on my phone. I'm not able to pull it up right now.
What about tomorrow?
Tomorrow, yeah, I'll try. Yeah.
Can we, like, after your group meeting, take a look at that and see if we can't get it running?
Yeah. Yeah, my only concern with that, I just have to bring my laptop, but that should be fine.
Okay. If it needs to be, if we need to set up another time, then that's fine too.
No, I think tomorrow should be fine.
Okay.
Okay. Thank you.
All right. Any other questions before I end the meeting?
Nope. Have a great day, everyone.
Yeah.
You too.
Yeah.